Hey guys, we're finally in chapter 4 and we're looking at linear functions and relations, and we're going to talk about in this section graphs of equations in slope-intercept form. So that brings us to our first vocabulary word, or our only vocabulary term that is, and that is slope-intercept form of a line. You guys should be familiar with this, y equals mx plus b. We know that the m refers to the slope, and the b term refers to the y-intercept. And what I want you to know is that this is not the only form of a line that you know of. Do you guys remember the other form of a line? I hope you do. It is called standard form. So when we have, this is different, completely different, but standard form is another way that we can see lines written. So standard form is, let's make that m, is ax plus by equals c. Specifically, our text describes it like this, and I think most texts do anyway, where a, b, and c are all integers. All right, do we remember what integers are? That's the next question. Integers are negative and positive whole numbers. So we're not talking about when we have fractions as a, b, and c. We want whole numbers. They can be negative or positive. Let's take a look at our first example. Example 1, it says write and graph an equation. So we're going to be given some information in this example. It says write an equation in slope-intercept form with for a line with the slope of 3 over 4 or 3/4 and a y-intercept of -2. Then we're going to graph the equation. Well, hopefully you guys feel confident writing this equation. We're going to start off with the form that we just were reintroduced to, y equals mx plus b. We're going to replace the m with the slope. So y is equal to 3/4 x. I don't like where that x is. It looks like I'm dividing by x. So I'm going to rewrite that so I can be clear about the fact that I'm not dividing. So we're going to have 3/4 times x. So let's try that again. One more time. Sorry, people. So 3 over 4, and I'm going to put an x right here. So you know there's no question. I'm multiplying by that x plus the b term. Well, the b term is a -2, so I could put plus -2, or I could just put -2, which is an equivalent way of saying that the y-intercept is -2. So now we got to graph it. So here's the fun part. Graphing is really easy when you have it in slope-intercept form. So what you do is you know that this is the y-intercept, right? And that's where the graph crosses the y-axis. So you're going to go to the y-intercept, which is at -2. And you're going to put a dot there because that is one point that is definitely on this graph. And the next part is you're going to use the coefficient here of x, which is the slope. We know that slope can be referred to as rise over run. And because of that, we can look at 3 over 4 in a sense as like a directional map as to how we can get the other points. So since 3 is positive and 4 is positive, as I'm looking at it here, I go up 3, 1, 2, 3, that's my rise, and over to the right 4. That's the positive direction when I'm going over to the right. I think that might have looked different. Anyway, over to the right 4, 1, 2, 3, 4. Is right here. So that's the next point on the graph. And that's all I really need, right? Is 2 points to draw a line. But let's say I was in a bind and I wanted some other points just to be sure. I can also look at 3 over 4. That positive 3 over 4 is a -3 over -4 because we know a negative divided by a negative is a positive, right? So since that's the case, I can think about the direction now is go -3 or down 3, 1, 2, 3, and then to the left 4. I feel like my left and right is kind of confused in the video, so I'm not going to do that. But go to the left, back to the other side. So 1, 2, I'm sorry, did I do that right? 1, 2, 3, 4. And you'll see that all 3 of these points are collinear, meaning they're on the same line. And let me see if I can do a good job drawing this line. I'm going to draw a line through that. Hopefully I hit all of it without it. That was pretty good. Let's just make the dots bigger. And there we go. There's our line. So let's go back. We figured out to make this equation was pretty simple. We plugged in slope, we plugged in the y-intercept, then we used that to graph by first going to the y-intercept and using the slope as kind of like a directional map. Go up 3 to the right 4 since they're both positive, or I could look at them as both negative, go down 3 and back 4. All right, let's go ahead and take a look at this next example. In example 2, we're going to graph a linear equation, and here we have this equation. I hope you guys recognize what form this is in. It is in standard form, if that's what you're screaming. I hope you are. And so what I'm going to do is take this from standard form and change it into y equals mx plus b because it is so easy. Somebody there is thinking, but wait a minute, Dion, didn't you tell us that we could graph using a table? Yes, you can, and that's totally fine. If you want to use a table, you can do that. And then somebody else is saying, didn't you tell us we could graph using the x and y intercept? And again, I'm going to affirm, yes, you can. But we're going to try a different way. Not that what you learned was wrong, just because we're going to learn a new skill. So I'm going to take this equation in standard form and I'm going to change it to y equals mx plus b form. And then I'm going to graph just like I did the last time. 2y is equal to 6. What I need to do, since I'm goaling for y equals mx plus b, I need to isolate y. Remember when we did those, what are they called? We did those literal equations where we isolated a variable. This was kind of one of the reasons why we're practicing to isolate a variable even when there's more than one variable in the equation. All right, that said, I'm going to get rid of the 3x. That needs to go away on both sides. So I'm left with 2y is equal to, watch where I put my 3x, minus 3x plus 6. It's not wrong if I put the 3x on the other side, but the reason why I chose to put it on this side is so I can better mimic or mirror the form that I'm goaling for. And the next thing is I need to get rid of this 2. To get rid of the 2, I'm going to divide both sides by 2. And when I say both sides, I mean both sides. The whole side needs to be divided by 2. When I do that, y is equal to negative 3 over 2x, because I'm dividing this part by 2 and this part by 2. And then negative 3x over 2, and then I'm going to add 3 to that. So the question is, do we have it in slope-intercept form? Yes, we do. Do we know what the slope is? Yes, we do. It's right here. Do we know what the y-intercept is? Yes, we do. So we have all we need to graph. So I'm going to go to the y-axis. I'm going to plop down a point at the y-intercept, which I know to be positive 3, given this this form and how I did all my work all correctly and awesomely. Since my slope is negative 2/3, I can look at this in negative 3/2. I can look at it in two ways. I can look at it as negative 3 over 2 or 3 over negative 2. Both would yield negative 3/2, which is my slope. So how do I rock this out? How do I use this as a map? Well, if I look at this pattern, I'm going to go down 3, 1, 2, 3, and then to the right 2, 1, 2. Plop, down 3, 1, 2, 3, to the right 2. Plop. So in a sense, I'm moving a negative direction for the y and then a positive direction for the x. But let's look at it in the reverse. What if I go in a positive direction for the y, but a negative direction for the x? So if I start here back at my y-intercept, I go up 3, 1, 2, 3, and back 2, 1, 2. Boom. Notice all collinear, meaning they all fall on the same line. And I'm going to try again to graph this. Let's see if I can do it. Let's see if oh, this is terrible, people. Do you know what I'm going to do? I'm going to fix this. You'll be impressed. You will say, Dion, you are a genius. I am just going to use a thicker pen. And so, haha, there we go. My line, okay, it's terrible. But you get the idea. If you had a ruler, you would use it to draw the line and it would be awesome. So that is my linear equation. Let me see if I could take that thing off. It looks terrible. I'm ashamed. All right, I guess that's better, sort of, not really, but you get the idea. All right, let's move on to another example, friends. Let's see what we got. This next one, these are, this example and the next one that I'm going to talk about are really examples that you want to hold on to in terms of remembering this. You guys learned this last year, but whenever you have y is equal to a constant term and there's no x here, this is probably the easiest thing for you to graph. It just means I don't care what x is, y has to be -3. So if x is 0, y has to be -3. If x, and that also happens to be the y-intercept, right? If x is 1, y has to be -3. 2, yeah. I think you got the idea. So we have this horizontal line. I'm going to try it. I even have a guide and I'm still messing it up. We have a horizontal line through -3. There we go. We have a horizontal line through -3. That's going to be our answer. So whenever we have y equal b, some b term, it's going to be a horizontal line through b. So this is always a horizontal line. I'm saying it over and over again so you don't forget. Horizontal line. Y equals something, horizontal line. So it's going to be a horizontal line through whatever b is. Did I mention it's a okay, never mind. It's a horizontal line. All right, let's go to the next example. This example is exactly the opposite. This is x is equal to 5. This isn't in your text. I don't know why they didn't bring it up now, but I think it's good too. X is equal to 5. You guys have seen this before. This equation has an attitude and it's saying, I don't care what y is. Whatever y is, I'm still going to be 5, says x. So we go to 5, 1, 2, 3, 4, and 5. And when x is 5 when y is 0, x is 5 when y is 1, x is 5 all the time, anytime, everywhere, and we get this. We get this beautiful vertical line. So anytime you have x is equal to some c term or a term or whatever, you're going to get a beautiful vertical line. With that said, the slope here is what? Do you remember? I hope you're screaming, undefined. It is undefined. All right, this is an undefined slope. If I think about it in terms of change in y over change in x, the change in y could be anything, but the change in x is always 0 because x doesn't change. And we know when we have a number over 0, that doesn't make any good sense, and that is undefined. Let me go back to this last example real quick, and I didn't talk about the slope here. If I think about the change in y over the change in x, the change in y is always 0, but the change in x can be anything, 1, 2, 3, whatever choices I choose. Therefore, the change in y over change in x here is always 0. So the slope of a line like this is 0. Okay? All right, let's see. How are we doing on time? I need to pause this. All right, our final example is to write a graph and linear equation. So we've got a couple of parts to this, and I hope you guys can see this okay. So example 5, to get Verizon Fios, a 100, and this is actually from my real life. I totally wrote this down, and we ended up not getting Verizon, but that's personal. Okay, to get Verizon Fios, a $120 installation fee is required, along with $80 monthly charge. So the first part is we're going to write an equation showing if we had gotten this, if we had gotten Verizon Fios, which we didn't, write an equation showing the relationship between the monthly charges and the number of months. So if I think about, we need to kind of define some variables. So if I use M as the number of months and my monthly charges as, I don't know, let's use P. So the price depends on the monthly charges, right? So the price depends on how many months. I'm sorry, the price depends on the number of months. So I'm going to write here, P is equal to $120, right? Because that's just the installation fee. I got to pay it. And then the amount I'm paying per month is $80 per month. So 120 plus 80M is what I'm going to get there as my equation. Of course, we can look at it for convenience sake as y equals 80x plus 120. So this puts it in y equals mx plus b form, really straightforward. And it uses variables that we're comfortable with. But don't be confused when you see other variables. That's okay as well. So this is my x-axis and this is my y-axis. The second part asks us to graph the equation. So we're going to graph that. Okay, I wanted to pause that to get a couple of, kind of an idea of how to graph this or what values I need. So I'm going to talk about months. I think it's pretty convenient just to use my horizontal axis and just count by 1, 2, 3, 4, 5, 6, 7, 8. Count by ones, and I skipped a space so it's not all bunched up. And along the vertical axis, I chose to count by 80s, but skipping a space, so each of these lines represent 40, all right? So this is 80, this is 160, this will be 240, so forth and so on. This guy will be 320, and that's how we'll roll. So now as I think about this, what I'd like to do is consider what the graph of this equation would look like. Well, my y-intercept is 120. Where is 120? If this is 40 and this is 80 and this is 160, this right here has to be 120. So 120 is how much I pay before I even have a month of service, right? So that's my installation fee. And then after that, I'm going to add $80